And how is it going to benefit you? Is it going to improve your training volume? Is it going to make you stronger?
All the above. I'm one of the big proponents of taking a lot more than probably what's recommended. But when it comes to set 2, 3, and 4, that's where creatine really comes to the rescue. And they measured it for 21 hours of sleep deprivation, and it really improved memory, cognition, and it increased brain creatine content.
Today, I'm joined by Dr. Darren Candow, who is a leading researcher in the creatine field and muscle aging. He's published over 140 papers on nutrition and exercise performance, how it affects muscle health, muscle aging. Darren, I'm super excited to have you here today, to have this conversation with you, to go deep into the science of creatine.
Yeah. No, thanks for having me. I'm really excited as well. Absolutely. Yeah.
I've read several of your studies. Great. I'm a huge fan. A lot of really important and interesting research to talk about.
Okay.
Maybe we could start where it's most popular. I mean, a lot of people think about creatine as in its role in exercise performance. However, there's been a lot of emerging research in other areas.
Yeah.
Maybe you could give people just a quick snapshot on.
Yeah, like it's really evolved over the last 40 years. It's gone from athletes getting bigger, stronger, faster. And now we're looking at potential benefits on bone health, brain health, cardiovascular health, even in children and during pregnancy. So it's evolved from just the young male athlete to pretty much anybody on the planet is now considering creatine either in their diet or supplementation. So for the next few hours, super excited to talk about all aspects of creatine and the evidence-based research behind it.
Well, let's talk about the resistance training and improving performance, muscle health. I mean, why is it so popular?
Well, because it works from a muscle performance perspective. So it basically increases the ability to produce ATP or maintain it during an exercise session. So, for example, when you're doing, a squat or leg press or even running, you're doing muscle contractions, and phosphocreatine, which is what we're going to be talking about today from creatine supplementation, it really maintains ATP or adenosine triphosphate. So if you have more ATP longer, you can exercise at a higher capacity, a higher intensity. And that delays the utilization of other energy systems that might be a bit slower. So anybody involved in high explosive anaerobic type of sports, weightlifting, high intensity interval training, for example, probably would experience some benefits from creatine supplementation.
And how is it going to benefit you? Is it going to improve your training volume? Is it going to make you stronger?
All the above. So it definitely seems to increase training volume. So that's either the load by the reps by the set or exercise capacity from a cardiovascular perspective. It definitely, if you were to choose one thing why creatine has been so effective, it's improving muscle strength. You could also encompass that with endurance and power. It also improves lean body mass. So here's a big discrepancy that a lot of the viewers might not know. When we measure lean body mass in the labs, we're technically measuring blood, connective tissue, soft tissue. So we're not directly measuring muscle mass. We need to do a lot more research on that. But in general, about 50% of the value of lean body mass we consider muscle. So it has some small favorable effects. There's been some studies with QCT as well as ultrasound. But you can get an increase in lean body mass, regional muscle thickness, muscle performance. But probably the area that most people don't realize is the recovery aspects. It really seems to have some anti-catabolic effects, potentially anti-inflammatory effects. And that's interesting because it's from the aerobic community. For the longest time, we never thought creatine was for endurance or aerobic type athletes. And the best lines of evidence from a recovery aspect come from long duration aerobic exercise, a marathon, ultramarathon, a triathlon. It seems to reduce cytokines. So those are markers of inflammation. So there's a whole gamut of mechanisms. There's about 10 what we consider anabolic factors, and then there's probably just as many as an anti-catabolic effect. So it has a plethora of benefits, which I'm sure we'll talk more about in detail today. Yeah.
So to go back, you just gave it total information dump, which is awesome. Let's go back first to the explosive power you were talking about. It seems to really help benefit in that explosive power, like you're talking about doing a squat, or I don't know, maybe the first few seconds of a interval, something where you're going, using all that power.
Yeah.
Is creatine benefiting? Is that how it's benefiting, increasing the training volume, or is there something else that's happening?
Yeah, in two ways. So it really seems to maximize either the recruitment or the ability of type 2 muscle fibers. And when we talk about aging, unfortunately, those are the ones we're losing as we get older. But it really seems to work in the second, third, and fourth set. So for example, if you were to do 4 sets of leg press, compared to placebo, you may not notice any difference in the first set because we think we have enough ATP or phosphocreatine stores in our muscle. But when it comes to set 2, 3, and 4, that's where creatine really comes to the rescue. The individual or group can do more repetitions, and then over time, they can actually do a greater volume. We think with weeks of training, if you're doing more volume, you can actually get greater physiological adaptations. So when we look at all the meta-analysis, when you compare creatine and weight training to creatine placebo and weight training, there is a greater increase in lean body mass, muscle size, as well as muscle performance. So creatine, there is something there from a mechanistic standpoint to allow that. And we think muscle fiber recruitment, primarily type 2 muscle fibers, is one of the main reasons.
Does it affect the recovery time in between sets?
Excellent question. It does. It really speeds it up. So on average, if you were to totally wipe out your normal creatine stores, it takes about 3 to 5 minutes for your mitochondria to recover that. However, creatine really, really speeds up that recovery, which is great for the average person. They don't have a lot of time to work out. They can't wait around for 3 to 5 minutes in between a really intense set. So it really speeds up the recovery. Not only does it speed up the recovery after every set, but in between contractions as well. So over time, the individual could probably have a really intense, great workout in less time total and get actually more favorable effects.
And I think what this is really important. We're talking about here, I mean, we were talking about squats, you know, these explosive types of power types of training.
Right.
And this is a really important field because, you know, you often hear about people talking about the loss of muscle mass as we age. You talked about losing type 2 types of muscle fibers more readily than the type 1. So these are the types of muscle fibers involved in that explosive type of power type of, you know, exercise. And, you know, people don't think about how power decreases with age, how, you know, strength decreases with age, and how that affects our quality of life, how it affects our physical independence, our fall risk.
Right.
And so I think just focusing on this type of training, I mean, the creatine is the icing on the cake, right?
Yeah.
But just focusing on doing these types of multi-joint compound types of lifts, which is something that I, in the past, I would say year, a good year now, a solid year of doing CrossFit type of training where I'm doing strength training, I'm doing resistance training, strength training, and high intensive interval training that's including, you know, the types of stuff that I'm used to doing, biking and rowing, but also adding in, you know, doing some drop sets with, you know, front squats with the barbell and things like that.
It's super important. So this velocity or power training or a variety training, first we got to get people to move, and then allowing them to give some type of benefit to their training program. So creatine is probably the one that will be number one when people select it, even probably more than caffeine nowadays from an exercise training capacity. So it should be considered. It can have a lot of substantial beneficial effects. And as we get older, after about the 4th decade, unfortunately, we start to lose these type 2 muscle fibers. And so exercise has to be foundational. And if anything else can be beneficial, protein, creatine, I'm all for it. And I think most people hopefully will be as well. Yeah.
So the improvements in the muscle strength presumably are coming because you're increasing your training volume, right? Is that, or is there a direct effect on strength?
Yeah, there's actually a neurophysiological recruitment. So now creatine has been touted as a new neurotransmitter. So this is quite interesting. It actually seems to release a lot of things from a neuromuscular perspective. But the biggest thing is the ability to recruit not only type 1, but these type 2 muscle fibers as well. And then, of course, if we're having greater muscle or motor unit recruitment, we can potentially lift longer, heavier, and over time get sort of more an increase in strength. The other big thing from a cellular perspective is that creatine causes calcium to come back in a little vesicle in our muscles. If you've taken high school biology or university, this will be your nightmare, but I remember everybody talking about the sarcoplasmic reticulum, and it's an area that just releases calcium to allow our muscles to contract, and creatine speeds up the uptake of calcium. So some of the evidence out of Europe has shown that it increases relaxation time or the ability of the the proteins in your muscle to grab hold of each other to contract. So there's a cellular aspect there explaining why we think we get an increase in muscle performance. I say strength, but endurance and power are all lumped in there as well. So endurance is the ability to perform repetitions to fatigue, or power, move an object as fast as you can. They're all vitally important, but we think strength is overall, from a global perspective, number one. It's probably the main reason a lot of older adults are placed in long-term care facilities. If they have a reduction in strength, they can't live independently. So that's why, again, resistance training or weight-bearing exercise, as you mentioned, CrossFit, whichever it is, foundational. I'm from Canada, so shoveling the driveway in the winter counts, because anything that's a load against you is really beneficial to the body. I think people underestimate the benefits of moving. And then if anything can be taken in this form, creatine, it'd be very, very beneficial. Yeah.
You mentioned some of the anti-inflammatory effects of creatine, particularly in the context of more endurance type of training.
Right.
People that are perhaps running marathons or just clocking in a lot of hours of running or cycling per week.
Right.
Is that so? I think that goes into some respect in the recovery sort of bin, right?
Yep.
And I'm wondering if that also plays a role in recovering from doing your resistance training or strength training, like on a recovery day. So, I mean, do you think it plays a role just broadly in recovery?
Yeah, it does. Now, this is interesting, and I probably would have been the most surprised when we wrote the paper on this, that we don't think traditional weight training, where you're doing a set, you're resting maybe a minute to two, it seems like it's not catabolic or intense enough. Now, most people will shake their heads, say, hey, when I'm in the gym, I'm really putting a lot of effort in. I think from a mechanistic standpoint, when you're doing running or long distance, continuous muscle contractions, it causes this large catabolic effect to the body. So that really heightens the inflammatory response. Weight training is acute. 10 seconds of work, 3 minutes of rest, 10 seconds of work, 3 minutes of rest, or whichever it is. And we just don't see creatine having a lot of superior effects from a resistance training recovery aspect, probably because the rest intervals for the average person are there. But from a long distance event, you're running hours, you're swimming, whichever it is. The best lines of defense come from triathlon and marathon running, where the increase in these markers called cytokines were elevated, but creatine sort of attenuated that rise. Could allow the individual to recover and get back on the track or whichever it is quicker. But I've talked to some good colleagues in Canada, and it just seems like weight training is too intermittent. Now, when you mention CrossFit, that's different. I'm thinking of the 3 sets of 10, you move from machine to machine, you rest, you have the CrossFit or something that's really continuous would probably fall in line here of the necessity for creatine. So that would be a very good study to look at the effects of creatine on the recovery aspects of something like high-intensity interval training or CrossFit, for example, our military type of training that's really endurance and resistance training. So you just gave me another idea to run with, but it's logical. The more intense, the more demanding, I think that's where creatine's anti-inflammatory properties would come into play. Yeah.
So when people hear catabolic, or they'll think of muscle breakdown, right? And certainly, there's a big component to sarcopenia, inflammation in sarcopenia, which is age-related muscle breakdown. Is there a role for creatine in preventing the breakdown of muscle?
There is. It's very mixed. So we don't have a lot of data. First off, creatine doesn't directly increase protein synthesis, which might be a surprise for a lot of reviewers. It sort of works in a magical other way, which we can talk about. But from a muscle breakdown perspective, it seems to reduce something called leucine oxidation, primarily in young males, and that's an indicator of whole body breakdown. We've also shown in our lab it reduces 3-methylhistidine, which is another indicator of whole body breakdown, but nothing is directly shown in the muscle itself. And for some reason, females don't experience this. We've looked at it in young and older females. We don't see the same effect. The only logical explanation is it could have something to do with progesterone or estrogen. We just don't know that. And from an anti-catabolic effect, decreasing some of these tissue repair mechanisms, there's not a lot of research out there. But unfortunately, we're not seeing any evidence that creatine increases protein synthesis. So unlike protein, which it does, creatine seems to help increase muscle size in other ways, satellite cells, growth factors, things like that. But it does decrease protein breakdown, primarily though in males. And we still don't know exactly why, but we think estrogen or the other sex hormones might be involved.
Does creatine have a general anti-inflammatory effect in both males and females?
It does in young and older individuals, but here's an important distinction. The more stressed the body is, it seems to come to the rescue more. So if you're a young individual, adequate sleep, proper nutrition, you're probably not going to notice any anti-inflammatory effects. It's when the body is under times of extensive exercise or trauma, hypoxia. I'm sure we'll talk about the brain and sleep deprivation. So whenever the body is more stressed or under more attack, that's when creatine seems to come to the rescue.
And circling back to, people that are supplementing with creatine and it improves their training volume, improves their strength. Why do people have to supplement with creatine?
Well, they don't actually. So a little bit of clarity. So we naturally are producing creatine in two main areas, in the liver and in the brain. And on average, we're producing about 1 to 2 grams. Then we're also consuming in the diet anywhere between 1 to 3 grams or none. So a vegan's not getting any dietary creatine. Those that are on a carnivore diet might be all the way up to about 3 grams. And we excrete through the urine a product called creatinine at about 2. So when you do the math, we're in a net surplus anywhere between 1 to 2 grams a day. And we know it's not essential because vegans can live a long, healthy, successful life. But we consider it conditionally essential because when we see all the evidence, I think there's over 1,000 peer-reviewed papers, when we take in a little bit more, there is some substantial beneficial effects across the whole board, not just muscle. We're now looking at bone, brain, and the immune system. Yeah.
So from a perspective of a vegan who is not getting any almost amount of dietary creatine, right. They're relying on their liver to make it. What's going on in their brain? You mentioned the brain makes creatine.
Yeah, it's very interesting. So on average, vegans have substantially less muscle creatine compared to an omnivore or carnivore diet. But an elegant study out of Brazil about 4 years ago, they used sort of an MRI for the brain, and they showed that vegans and omnivores had the same amount of brain creatine store. So that's really substantiating that the brain makes its own creatine. It probably makes enough for the non-stressed individual. But during times of metabolic stress, the question is, will vegans or omnivores need more? And it's likely that that's true, yeah.
During development, is the developing brain making its own creatine like...
It is, yeah. Just like our liver is making its own creatine, it's using, and it's probably at an accelerated rate for brain development, cognitive development. Again, our brain is small, but it uses 20% of our daily energy. And of course, during development, that's when it's very, very precious as well, yeah.
So creatine is mostly found in animal foods,
correct,
meats,
yeah.
Poultry, fish.
Yes.
None in plants at all.
Trace amounts. You'd have to eat the entire orchard of whatever plant you're thinking. And same with milk. You'd have to drink all the milk from a Jersey cow to get any significant amount. So that's why it's unrealistic. Yeah.
So if we're producing between 1 to 2 grams
at best, yeah,
just in our liver,
correct, yeah.
And that presumably then is being transported to muscle.
That's the hope, 95%. We can't forget about the bone and brain are the main areas. Yep.
Okay.
Yeah.
And then if let's say you're getting, I think I was reading some NHANES study where on average people get, younger adults, not older adults, get anywhere between 1 to 2 grams a day from their diet.
Right.
But older adults are getting on that lower end, not even necessarily at 1 gram. So older adults are getting even less.
Yes.
But then, is there more to be consumed by the muscle, or does it get spread around? Yeah,
that's an excellent question. So the thought is, as we get older, we have reduced phosphocreatine stores in our body, so they might need more. And the hope is about 95% is housed in our skeletal muscle. But now with the emergence of research, the rest is in bone and brain specifically. So the hope is if we take in more, our muscles will be full, which is great. But now, hopefully, we're going to have some trickling into our bone, which is even just as important. And I think most people would argue from the neck up, that's really important from a global perspective with all the neurological diseases, depression, anxiety. So I'm one of the big proponents of taking a lot more than probably what's recommended based on the evidence-based research to sort of disperse throughout the whole body, not just skeletal muscle.
Well, let's talk a little bit about that. So in some of these, the strength training, resistance training studies, what's the common dose that's taken? And maybe we can talk a little bit about, there's the loading phase, which I've never done. So I actually take 5 grams a day.
Okay. Yep.
And although I might start taking more after this podcast.
Okay.
So I'd love to know, like, what is the average dose that's taken to improve, your strength training, your resistance training, your training volume, and then we can go from there.
Yeah. So, I mean, in 1992, Roger Harris came up with a seminal protocol where, as you just mentioned, this loading phase, it's the most viable, rapid way to really saturate your skeletal muscle. This has nothing to do with the bone or the brain. And so that's 20 grams a day for about 7 days is usually what's recommended. A bit of new information, you only need to do that for 2 days, and then your muscles are saturated. So the loading phase was designed for athletes to really rapidly sort of fill up the room, if you will, from a skeletal muscle perspective. After that, you can reduce it as little as 2 grams a day. So again, that's a half a salmon steak. That would be a half a chicken breast or whichever. So it's very viable. They call that the maintenance phase. The only problem with the loading phase is it's so rapid, it does cause water to enter a lot of our cells, and a lot of individuals do not like this potential net water retention or GI tract irritation. We don't usually use that in our labs for that reason, but for the athletes, World Championship coming up, the loading phase followed by a maintenance phase is a very viable, rapid way. Young females hate it because of that water retention and weight gain. The good news is you can take as little as 2 to 3 grams a day, no loading phase, and take that on a daily basis, probably for the rest of your life, and that will definitely accumulate and fill up your muscles in about 30 days. We don't know if that low dose will get into the bone or brain on a long period of time. What we've done is look at a relative dose. So that means everybody has a certain weight. We put them on a scale, and we use 0.1 gram all the way up to 0.14 grams per kilogram. So, for example, if you're 70 kilograms, you're taking 7 grams a day all the way up to about 9 grams a day. You can take that in one bolus dose or split it up into smaller dosages throughout the day. I wouldn't go any less than 1 gram. 1 gram doesn't seem to get in the blood as rapidly as we need. So that's something for your viewers if they're microdosing, no less than 1 gram. But you can split it up 2.5 grams, 5 grams, whichever you want. I take a lot more than that based on our new clinical data. I'm 48 years of age. I know the effects of aging and from a bone and brain perspective. But really, all this dosing came from muscle. And we have all these new areas. That's why I think the emergence of new dosing strategies has really come to light. Yeah.
I definitely want to get into some of these, potentially negative effects of the high dose.
Right.
But let's talk a little bit about your new emerging data on bone health.
Yeah.
And so you're talking about, so I mentioned 5 grams a day, and well, maybe before we get to that, how long does, if I'm taking, if someone's taking 5 grams a day, and how long does it take to get your muscle stores saturated?
Yep.
And then let's say your resistance training, right? So you're working, let's say your resistance training and endurance training. I mean, you're working out 5 to 6 hours a week.
Yeah.
I'm just talking about my schedule here.
Yeah. Okay. Yeah.
And then, I'm doing 5 grams a day, right? Am I just constantly saturating my stores, even though I'm, pulling down from them as I'm working out? Yeah. Or how does that work?
Perfect. Because 5 is the average global recommendation, and that's a fantastic dose overall, we think, to start, especially from a muscle perspective. So it'll take you 21 days to fully saturate your skeletal muscles. So after that, you're going to have some being excreted in your urine, or let's pray here, hopefully some is now being uptaken into your bone, because the muscle is pulling on bone. Your bone is a very metabolically active tissue, which no one actually sees in the mirror. And then hopefully some is trickling more into your brain. So the thought is, okay, 5 grams is very viable. Easily 21 days, your muscles will be full. Taking 5 grams a day thereafter, some would probably go in the form of creatinine. But hopefully, and we don't know this, maybe some is going into your bone, being used by your immune system, your GI tract, your gut health, and your brain. So 5 is a great dose. I'd like it to be higher just because of some of the new data to suggest every day we get out of bed, we're a day older. There's some good evidence to suggest bone needs a bit more. And of course, the brain, we still don't know, but I have some lines of thinking about when we're really metabolically stressed, how much to take. But if you're taking 5, rest assured, you're doing exceptionally well. Yeah.
Well, let's talk about bone. So one of the best things you can do for bone health is weight-bearing exercise, these compound lifts, the things that we were talking about with improving your explosive power and your strength, right?
Right.
How is creatine adding to that?
By 2 ways, a direct and indirect. So let's go with the boring direct. It sort of increases osteoblast cells. These are the cells that sort of create or the formation of our bone cells. So in rodents, osteoblast cells have been energized in the presence of creatine. So it was logical to think in humans, maybe our osteoblast cells, the cells that are responsible for increasing bone size and strength, might have more fuel. And these cells do use creatine just like our muscles do for fuel. And potentially increase bone density. And if that's true, we've just cured osteoporosis, basically. The other line of thinking, which is surprising, going back to this anti-catabolic phenomenon, is the best lines of evidence with bone are from an anti-catabolic perspective. It seems to resemble a bisphosphonate. So a lot of reviewers are maybe taking a bisphosphonate. It sort of preserves your skeleton. I know my mom is taking that as well. So creatine reduces something called the osteoclast activity or bone resorption. So for some reason, it really inhibits these osteoclasts from sort of chopping down our bone and increasing blood calcium levels when not needed. And then, of course, if it sort of increases osteoblast potential, maybe the recycling of bone gets stronger. It's kind of like laying a foundation of a house. The bricks are stronger. You're sort of putting the bricks together a little bit faster. And then inclement weather is not chopping away the bricks or the cement. So that's how we theorize it was working. And there's been about 15 studies now showing that it has a lot of anti-resorptive effects. So think of anti-catabolic to the bone. We have not shown in a single study an increased bone mineral density. So this is really crucial. We are not saying that creatine and weight training increases bone mineral density, but it certainly decreases bone mineral density loss, and really specifically around the hip region, which is crucially important for a lot of older adults, because when they fall, if they land on their hip, they could be more susceptible to fracture. So there's a lot of anti-catabolic effects, and we've just shown in a long-term clinical trial an improved bone strength. So picture a pen or pencil. You can't crack it as much there. I think weight training is the main driver when it comes to bone. The more muscle you have from an indirect perspective, there's more muscle pulling on bone, so that's very beneficial. Look at gymnasts. They have phenomenal bone mineral density and muscle mass there. So there's a lot of potential there. It's not overwhelmingly convincing, I think, because bone takes a long time to turn over. But this is interesting. The lowest dose ever been shown to be effective is 8 grams of monohydrate a day. Now, as we just talked about, 3 to 5 grams is great for muscle, but now you're getting into bone. What needs to happen is a dosing study. Could 5 grams over maybe 2 years be equivalent to 8 grams over 2 years or even higher? That is very expensive to do, but it's been in the back of my mind. I would just speculate that 5 grams over time will still benefit your skeleton, but you need such a large sample size to get these small effects either from a DEXA or CT scan, and that's probably why we haven't seen it yet. But in all our clinical trials, 8 grams. But the Brazilian group have looked at 1 to 3 grams for 2 straight years and not a single improvement. So weight training is there, and I think that's the big driver for many of the muscle bone perspectives. Yeah.
So you think just supplementing with creatine by itself, even if you're doing 8 grams, isn't really going to necessarily affect your bone health if you're not doing any weight-bearing exercise, even considering the, preventing the breakdown, preventing the activation of these osteoclasts that are breaking down the bone?
Right. I would be very surprised. I think you need that mechanical loading from weight training or weight-bearing exercise, plyometrics, to cause the bone to turn over, and then maybe creatine doesn't increase the resorptive, or it increases osteoblasts a little bit more. The cool thing with osteoblasts, it releases this cytokine called osteoprotogerin, which acts as a decoy. And that's been shown in vitro studies there. So there is some cellular data, which is a bit surprising when it comes to the skeleton, not just imaging. But if I was to take 8 grams, would I tell my parents to take 8 grams and not work out? If I did, I don't think they'd expect anything on the bone. The bone is really stubborn. It's just like our brain and creatine. It's really, really stubborn. I think the main force is the driver of weight training. Yeah.
What about someone who is, let's say, a postmenopausal woman who's experiencing some perhaps osteopenia?
Yes.
Do you think before trying some of these other standard of care treatments, like bisphosphonates, for example, you mentioned, doing the weight-bearing training and the creatine, perhaps 8 grams or 10 grams a day, would be a good first line of defense to try before trying some of these other drugs that do have negative side effects.
So if you're in line for a bisphosphonate, there's no way that creatine or weight training will come close. So a drug effect will always be superior. The effects we're seeing even from a significant perspective with creatine are so small, we don't even get to a clinical perspective. But let's talk about weight training. I 100% agree. If I had to choose one for bone, it's weight training or plyometrics or anything that you feel to the body, and then consider creatine in your treatment program. Creatine would never replace a pharmaceutical intervention from a bone perspective. And the effects we're seeing are so small, or even over 2 years. At best, it's preserving. Now, this begs the question, maybe the adults we chose were too healthy. None had diagnosed osteoporosis or osteopenia or frailty. What if we took a population with severe osteoporosis? Maybe creatine could come to the rescue there. That's another thing we're starting to hopefully get governmental funding for down the road. But a lot of young females, a lot of young males, and of course older females, even postmenopausal, their skeleton is still very beneficial and strong. They may not have incidences of osteopenia or fracture risk. But until we do a study in diagnosed osteoporotic males and females, we just don't know if it's the disease or maybe they were just healthy enough. Yeah.
Well, prevention is obviously, I think, the key, right? If we can encourage people before they're experiencing massive breakdown of their bone or osteoporosis, osteopenia, to, engage in resistance training and not the single joint exercises where you're making your biceps bigger, right? I mean, like you need to be doing these multi-joint compound lifts, rows, presses, anything that's multi-joint. And then perhaps in combination with creatine, if it's preserving bone, that does really suggest a preventative role, right?
Yeah. And that's 100% correct. Like the movement is got to be there. And I think most people are aware of the benefits of exercise. And then if creatine or protein or whatever it is you're eating can give you a small beneficial effect, I'm all for it. And I think a lot of people would be there as well. So creatine definitely has the potential. It kind of has a lot of potential for a lot of things. But without protein, those two need to be there. We don't think creatine can rescue a hypocaloric diet, especially low in protein, but we just don't know. I argue that creatine falls in line with protein with its aging anabolic resistance. As we get older, my guess is where we have lower creatine in some of our muscles as we get older, we need more. So now there's a young versus older stereotype, just like protein. Younger individuals may respond from 20 to 25 grams all the way up to older adults. So I think creatine is definitely a part of my day. And I try to promote the evidence-based research, especially from an older adult population. If anything we can do to offset chronic disease or getting chronic disease, that's beneficial. And we're starting to really focus on young females. Exercise is so important, adequate protein, and then creatine. It's not just for males. We're seeing a plethora of benefits for young biological females, which is really important. Yeah.
It is. When you hear the word creatine, you think about like the gym bro, right? Like, I mean, it's like, you're taking the creatine, trying to get, their muscles bigger. Right. And the reality is that, women are also very susceptible to, they're susceptible to, losing muscle mass and strength, but bone is a big one.
It is,
right?
Yeah. And when we look at all the data, females get an improvement in muscle performance, primarily strength. That's the population we've seen the best bone benefits. Now, they were postmenopausal, but reduction in bone mineral density, bone strength. And then we're seeing from a sports perspective, agility, balance. So for the females watching, don't shy away from creatine. It's extremely potentially beneficial in combination with exercise. And if you're worried about weight gain or whichever, do not do the loading phase. It's not needed. You can start as little as 2 to 3 grams a day. Divide that up even. So I'll tell a lot of our clients or participants, you can take 1.5 grams in the morning, wait till the evening to take 1.5 grams. That really decreases the chance of water retention. But if you're eating red meat or seafood, you're getting a little bit amount. For the vegans watching, keep in mind you're not getting any, and that's why supplementation, third-party tested, they are vegan-based, could be considered. Yeah.
I mean, it seems like it'd be very important for that population of people in particular.
Yeah, we've done some really fascinating studies with vegans and vegetarians, and they respond exceptionally well because we're doubling the amount of creatine, which is the high-energy compound in our muscle. So those individuals can do more repetitions, higher volume, quicker recovery. So it really has favorable effects for male and female vegans and vegetarians. And again, those emphasizing a plant-based diet. With everything going on in the world nowadays, a lot of people are looking to more plant-based diets for health reasons or whichever. And then they might need to consider a supplement. So usually we're not in the market of talking about supplements, but this one is the one that seems to come to mind where it might be difficult to get the amount needed in your diet from financial costs, ethical treatment of animals, whatever your own habitual preference is. And if they're third-party tested, it's the safest, most effective ergogenic aid out there right now. The safety profile is exceptional, especially at the dosages we're talking about. Like when we talk about protein, we're talking hundreds of grams. At most, we're talking maybe 10, 20 grams for the athletes, which is basically 2 teaspoons in the run of a day. So it's not a lot, but there is a lot of evidence-based research behind it. Yeah.
Yeah, and we'll definitely dive a little more into the supplementation. But I'm interested in the brain, and we've gone from the role of creatine. It seems to have multiple roles: anti-inflammatory, anti-catabolic.
Right.
It's obviously important for producing ATP, regenerating the ATP. What about the brain? What's
super exciting? Like this is such an emerging area. So from the neck up, I think the next 20 to 30 years will be focused almost entirely on this. So our liver produces creatine. And our brain actually is unique. It also produces creatine. But the brain is very resistant. We have the blood-brain barrier for a really important reason. And the brain says, you know what? Circulation, we don't need creatine in the blood. We're making our own. So an individual getting adequate sleep, no chronic disease, no metabolic diseases, no neurodegenerative diseases, is producing adequate amounts of brain creatine. It could be as little as 1 to 3 grams. Now, our brain is small from stature, but it uses 20% of our daily energy. And of course, as we all know, when you're really tired, sleep deprivation, running around chasing your children, most people that I know are really metabolically stressed, primarily from a cognition perspective. And that's where creatine seems to have the best lines of evidence. Sleep deprivation, hypoxia, jet lag. I was up at 3 o'clock this morning and flew down. So I'll be taking a really high dose today to hopefully offset the chance of inflammation or cognitive decline. So when we look at the totality of emerging evidence, it's split. Some studies don't see any effect, but the ones that do is in a population where they're either mentally fatigued, sleep deprivation, or during times of aging, and that's where memory comes into play. And the common denominator seems to be the more that the brain is stressed, the more creatine seems to come to the rescue. Same analogy from a muscle and bone perspective. So we can talk for hours just on the brain, and it's a very exciting area for sure. Yeah.
So the brain is stressed. So brain aging.
Aging.
Older adults.
Yeah.
That's aging is a stress on the brain.
It is.
So supplementing with how much creatine can improve cognition in, let's say, older adults.
Yeah. As little as about 5 grams has been shown to have some potential, but this is interesting. I just 20 minutes ago said that the loading phase wasn't needed for muscle. The best studies for the brain look at 20 grams a day for at least a week. So now you're in a conundrum. I'm looking at muscle, bone, and brain. And the theory here is that since the blood-brain barrier is very resistant to creatine, and unfortunately we have this really important glial cell called astrocytes, which are the biggest in our central nervous system. It sort of acts as a filter from our blood into our cells, and it really determines what gets in. And it says, hey, foreign pathogens, no, you're not getting into the neuron or the cell. So unfortunately, they don't have the creatine transporter or doorway. So that's why uptake into the brain is very blunted. So the thought is to get an improvement in brain creatine stores, you need longer duration of supplementation or higher dosages. So the best lines of evidence using MRS have shown that higher 20 grams a day seem to be the most viable. There's been a single study looking at about 4 grams a day, but it took 3 months to accumulate in the brain. Unlike our muscle, which acts as like a vacuum, it sucks in all the creatine from our blood. Our brain says, no, I'm only going to take what's in our blood, i.e. supplementation, when need be. So that's why sleep deprivation seems to have the best lines of evidence, or mental fatiguing challenges. Yeah.
Okay, so if you're someone like myself who's been supplementing with 5 grams a day for a year.
Okay.
That's enough time for it to eventually accumulate into the brain, presumably.
Yeah, like that low dose, remember, you need about 2 to 3 grams. Now, I'm not sure about your diet, but you're going to need that just to maintain your muscle. And then comes down to your genetics. What's more in jeopardy? Is it your bones or brain? So again, the 5% that's remaining throughout the body is in your testes, heart, bone, and brain. So for me, as a biological male, it's going to different areas compared to you as a biological female. But my hope is, wait a minute, let's go a bit higher. So we're sort of checking off all the boxes. My guess is 5 grams. You'd have a small increase in brain creatine content. But if you have a really non-stressful life, the brain says, no, go to the bone or we'll excrete it down the toilet. But if you're metabolically stressed, it's begging for more. I'd like you to be probably higher than 5, but I think it'd be interesting to look at some pre-post MRS scans, and it's viable. It could be there. The study that did 4 grams was in long COVID. These individuals, brain fog, fatigue, headaches, things like that. So the brain was really begging for recovery. Yeah.
Okay, so you just mentioned the best studies showing any improvement in, and when we're talking about improvement, we're talking about cognition, we're talking about like
memory.
Yep. Okay.
Yep.
You said 20 grams, right? Which is definitely what I don't want, the swelling part of that, which happens around 20 grams.
Yes.
So have there been studies looking at 10 grams? Is that like a sweet spot?
The seminal study was out of Germany, and they did 2 versus 4 versus 10. And this is where I personally take at least 10. And they use MRS studies, and they showed that about 10 doubled the percent increase in brain creatine content, but they also measured it in the gray matter, the white matter, and I believe the thalamus, and it all improved by about 10%. Now, it was a small sample size because to run an MRS is super expensive. So statistically, it wasn't there, but the percent improvements were a lot higher. And when you look at all the other data, 10 grams seems to be a very viable dose to not only check off the box, definitely for muscle. We're now checking off the box for brain, and now bone, and then we're also checking off the box for brain as well. So I personally take about 10 grams a day on average, but during times of metabolic stress, sleep deprivation, or jet lag, I'll increase it to 20. So today I will take 20 grams because I flew down from Canada. I'll take 20 grams again tomorrow, but when I get back home, I'll decrease it back down to 10. If any is being excreted down the toilet, I'm totally fine with that. Creatine is very cost effective, but I want to make sure I'm maximizing all my abilities. And the immune system, especially in Canadian winters, is really heightened and activated. And I really have found in the last few years, I'm not getting flu-like symptoms. Hopefully that's from exercise or diet, but who knows? Maybe creatine is helping because there is some anti-inflammatory effects.
Yeah. You went to another area that I definitely want to talk about, but like before that, so 20 grams, then you're saying acutely when you're in this sleep deprived state, jet lag, let's say fill in the blank type of, extreme stress.
Right.
Is that immediate? So let's say like you're like up late. You're up late one night and you have something to do the next morning or the next day. You have to be like on your game. If you take that 20 grams either at night, would you take it at night? Like before you go to sleep or in the morning, or does it matter? And will it have an effect immediately? Yeah,
and I love learning. And this is just, so 20 grams might be too low. It's surprisingly to your viewers. So another study came out of Germany. They did this very elegant design. It was a crossover, and they gave 0.35 grams per kilogram. So even if you're only 70 kilograms, that's 25 grams in a bolus dose. And they measured it for 21 hours of sleep deprivation, and it really improved memory, cognition, and it increased brain creatine content. So that high a dose, not only does it get into your plasma or blood really quickly, probably in about 3 hours it's peaking. When your brain is stressed, it's being taken in quite readily. So during times of metabolic stress, it seems to work. Now, the argument is, how do I know I'm going to be stressed tomorrow? How do I know I'm going to have a bad night's sleep? You don't. So that's why I think taking a higher daily dose might be a safety. But the days you're like, oh, I didn't sleep at all, and I have a big presentation later, or me as a professor teaching 4 classes a term, I've really increased the amount. I would say I might be the most saturated person on the planet because I've been taking creatine for decades. There's no reason to stop. We can talk about cycling or continuous. But I'm even taking more in hope that it's getting into my brain. Again, 20 years ago, it was just muscle. then we've evolved into the bone, and now we're getting into the brain. And I think a university students, midterm week, final exams, staying up all night, cramming, maybe creatine could really improve their ability to score better on tests. And when you look at the mental fatiguing studies, that's when creatine seems to work. After you've done a whole bunch of fatiguing exercises, taking creatine before, it really speeds up your ability to maintain memory and cognition. And we can talk about neurofilament things in the brain, or BDNF, and that's some of the mechanisms primarily in rodent. So there is some mechanisms showing that creatine is decreasing oxidative stress, or really having some potential for neuronal health, which now you think of Alzheimer's, dementia, neurodegenerative diseases. So I'm super excited to see where this is going for the next 20 or 30 years. Yeah.
I wonder if there's any effect just because it was sort of a triaging of like it's helping with the energy. And so it's like freeing up other energy, for like other, taking care of oxidation
and that's
like
probably
that,
the best overall segue. So it increases brain bioenergetics, and if it can, one of the common denominators with depression or concussion is that they have reduced brain creatine stores and bioenergetics compared to a healthy control on average. And so maybe creatine is bringing those values up, or even slightly more. And now the brain has more energy capacity to do and deal with all the daily stressors of society. Yeah, absolutely.
Yeah. So TBI, traumatic brain injury. The way I think of it is like real-time brain aging.
Yes.
It's like all of a sudden you just get a knock to your head, and it's like accelerated aging. So what would be a protocol for someone that, let's say they take a blow to the head, or they get hit with the ball, a soccer ball, or, whatever, the football, whatever sport that they're doing? Would it be like they should be taking high dose immediately?
Yes. So I'm now in the camp, and I think a lot of other researchers, and a lot of the work's coming from here in the United States. But if you're in contact sports, creatine should be taken on a daily basis, because unfortunately, if you do get hit, in the rodent model, because you can't do this in humans, but when they've actually forced concussion in rodents, taking creatine beforehand, the recovery symptoms are really accelerated. And in the only single human study was in children. As soon as these people in Scotland got head trauma, they put them on 0.4 grams of creatine per kilogram. So about 20 grams. These are just children immediately. And over 6 months, these children that were taking creatine had substantial improvements in self-care and efficacy. No blood biomarkers were taken, but at least it showed the improvement in recovery. So instead of waiting till you get hit, why not take the preventative role? And that's why, again, I think for me, and again, it's opinion, but we've seen some data to suggest that 10 grams might be a good viable dose, more or even a little bit less, depending on why you're taking it. But I personally take it from a whole body perspective. I don't play any contact sports now, but who knows? I could go out and skate and fall and hit my head, or skiing or whichever, and maybe that would help accelerate recovery. I'm taking it just for any chance to have some potential brain benefits. But the big area is it does increase the recovery aspects of concussion. So NFL, NCAA, especially down here in the United States, $1 trillion industry. I got to believe these players are taking creatine in anticipation. I know the quarterback for the Dolphins, I think he's had 3 concussions this year. So his brain is so compromised right now, massive inflammation. Hopefully his medical team is at least considering high dose with his other treatment program to get there. So, yeah.
And they should be taking it for the benefits on muscle,
Absolutely.
and explosive power.
Exactly. Yeah.
Those, high intensity moments. You mentioned earlier about 0.1 grams per kilogram body weight. So how would you adjust, let's say, you're taking 10 grams of creatine per day, and you're wanting the effects, the benefits of muscle, bone, brain, as do I.
Right.
However, I do not weigh as much as you.
Right.
So is there a scalable amount per kilogram body weight you think would be something that... Or is it hard?
That's an excellent question. And the answer would probably be no, because when we go on the scale, we don't consider the head, even when we do DEXA scans, as headless. So, if I'm 80 kilograms, I'm taking there's the sweet spot, about 9 to 10 grams a day. Taking it from a weight perspective to correlate to the brain is almost impossible, because we need to measure the weight. And where it's a hard tissue, it's a little bit soft, but it's usually hard tissue. I think overall body weight, very similar to how people do protein based on lean mass or a total body structure. So you can take creatine based on lean body mass, but it's very difficult. You would have to have some type of imaging apparatus. So we just usually recommend it on body mass to hit all the aspects. Yeah.
That makes sense. And it really does seem like there's this sort of triage triaging where it's like, okay, the muscle's consuming it.
Yep.
It's like the greedy one. And then whatever's left over, maybe the bone. But if the brain's stressed, well, maybe it's funny how the body can figure that out. Like, no, the brain needs it.
Yeah.
So, there's some interesting research that you also published kind of in the brain area is sleep.
Yes.
Right. And I'd love for you to talk about that study. I thought it was so interesting. These resistance training females, and you gave them creatine, and it really seemed to help improve their sleep on training days.
Yeah, it was colleagues at University of Idaho, and Brown and CJ Brush, and they looked at young, healthy individuals, biological females, and we gave a pretty high dose here, 5 grams, plus we added 5 grams of placebo, so 10 grams a day versus a 10-gram placebo. And this was done for 6 weeks, and they resistance trained with a tonal home gym for 2 days a week. And the interesting thing is total sleep duration on the days they trained was substantially higher. I think it was about almost an hour compared to placebo. And again, these are young university-age students that were taking creatine, about 5 grams a day. The nice thing is it also improved strength. There was no big fluctuations in weight gain, which was very, very interesting. No adverse effects. Now, there was no mechanisms assessed, but the logic was that on the days these individuals are training, maybe they put in more effort. So creatine helped recover the body a little bit more, allowed that body to be in repair mechanism a little bit more. And they slept more for about an hour on average more. We still don't know the exact reason, but it is interesting that it improves sleep duration. Yeah.
And it's almost kind of the opposite of what we were just talking about. Where you're talking about if you're in this context where you're jet lagged, you're sleep deprived, and you take the creatine, and it kind of helps you get over that brain fog that, like, you're not quite, on your game.
Yeah, it goes against most of the comments I get where when people take high dose creatine, some people say they feel like insomnia or intermittent sleep. And the theory there from a rodent model out of Belgium is that maybe the brain is recovering quicker, that it doesn't need to sleep as long. So we still need a lot of work to do. We need to look at different stages of sleep. I'd really like to look at some blood biomarkers, indication of what's happening from an inflammation perspective. So there's a lot of work in that area to go, yeah.
The other thing I was thinking about, Darren, was, adenosine.
Yes.
Is there a role? Because, it's downstream of ATP, right? So I'm wondering if there's any role, because adenosine is something that does make you sleepy.
Yeah. I always think of caffeine, the adenosine.
Right.
Yeah, no, it's possibly there. There's been a lot of speculation. They thought also glycine is implicated, and where glycine is involved in the synthesis of creatine. So there's a lot there. I think we'll talk maybe about homocysteine a little bit later in the methyl. So there's a lot of areas to look at, and I think we thought we knew everything about creatine, and now it's taken on a new life of its own. And again, I'll have a job for maybe 20 or 30 more years looking at this. So yeah.
Before we continue, I just want to mention something important. If you're finding these episodes valuable, please consider subscribing to the channel and clicking the notification bell. It's the only way to ensure you'll be notified when a new episode goes live. Many people assume they'll be alerted automatically, but unless the bell is clicked, they won't be. We cover a lot of detailed evidence-based content here, and I want to make sure that you don't miss any of it. Now back to the episode.
Well, let's go back to the brain and talk about so we talked about brain aging, traumatic brain injury, which is stress. We talked about lack of sleep, anything that's stressing the brain. Well, I guess, neurodegenerative disease is a very stressful thing on the brain as well. It would be interesting to see if creatine can help in that regards. Although, again, prevention is always it's always better, right? If you can.
Yeah, we've looked
help.
at the totality of limited evidence, and we're not seeing a lot of effects yet. There's benefits on young boys with muscular dystrophy, but that's a little bit different. But when we look at ALS, Parkinson's, Huntington's, multiple sclerosis, all those dementia and Alzheimer's, we're not seeing a lot of promise. There's been a few small-scale studies that show benefits, but when you look at a properly sample-sized study, there was a big one 5 years in Germany, didn't see any greater effects. So again, maybe the dose was too, when I look at the dose they use, it was very small compared to now our body of evidence suggesting higher dose, big sample size. And then, of course, what about the effects of the disease? Can creatine really rescue the effects to give a significant effect? We don't know. Preventing would be the number one thing, but we're starting to do a study in northern Iowa to look at the effects of creatine now in individuals with cognitive decline. And I believe there's a study out of Kansas that are actually looking at people with diagnosed Alzheimer's. So super excited to see these results. If it can have any effect, even help one person, even regardless of a statistical effect, if it can have individual results, I think it's something we need to consider. Yeah.
Okay, well, what I was going to get to was the other part of, brain disorders. You have neuropsychiatric disorders. You have depression, anxiety. Those are also unfortunately very common nowadays, even in younger adults and adolescents. So there's been some interesting research with creatine and depression.
Yes, there has. It's an emerging area, primarily to Utah. There's a great psychiatry group there. And as a caveat, no study has ever looked at creatine without antidepressant medication. So they're always as adjunct. So we're not saying creatine could ever replace anxiety or antidepressive medications. But in these populations, primarily females with clinical depression, it's really starting to have some speed up recovery and decrease some of the symptoms. The mechanisms are starting to emerge. It's starting to have a role primarily from rodents, and this is implicated in depression where they have reduced brain creatine stores, so maybe creatine supplementation can bring those levels up. There's potential to increase BDNF, so that has been implicated there as well. And there's another thing called neurofilament or light chain. It's an indication of neuronal damage, and 1 gram of creatine in your diet has been shown to reduce that. So there's potential there, but the overarching thing with antidepressant is it increases brain bioenergetics, as you mentioned, and decreases, again, here we go, mitochondrial health, decreases reactive oxidative species. All these are implicated in all the brain and cognitive decline and primarily depression. So I'm really excited in that area. A big RCT needs to be done, though, because it's always being added to either cognitive behavior therapy or SSRIs. Yeah, for sure. Yeah.
And there's also a big inflammatory component in depression. There's inflammation. In fact, there have been studies just in healthy young individuals where they induce inflammation through like LPS. It can cause depressive symptoms.
Yeah, and 100%. So the anti-inflammatory role comes back there as well. So you'll start to hear these two words, anti-catabolic and anti-inflammatory. People think of Advil or Tylenol from an anti-inflammatory, but creatine seems to work very similar in the COX inhibitors as well, and but it seems to decrease cytokines. So it could be something there to consider. Yeah.
Well, what's interesting is, activated lymphocytes, T cells, consume just enormous amounts of energy, and to basically become active and fight off pathogens. Right. And so I'm wondering if creatine is taken up by, these immune cells and it maybe helps in some way. I mean, you're saying it reduces cytokines. I mean, a lot of these T cells are, producing cytokines to fight off things, but who knows if they have that energetic boost, how that could affect, just, I would say like the broader, like not having this huge kind of war going on, right?
Yeah, there's been some cellular data around the immune system cells, around creatine, specifically around T cells or macrophages. That's where the anti-cancer idea came in from creatine, specifically like regarding lymphoma, leukemia. So that's more in vitro. There's a lot of work needs to be done, but there's a lot of studies now looking at the anti-cancer potential of creatines, primarily from the or the heightened immune system response. Yeah.
I wonder if there's any, has anyone ever looked at creatine's role in helping prevent infectious, disease or respiratory illness, fighting off pathogens. Like just anecdotally, I supplement with glutamine and creatine. My 5 grams of, it's about 5.6 grams of glutamine I take a day, and with creatine, 5 grams of creatine. And it has made a insanely big difference in my susceptibility to respiratory illness, which I have a little 7-year-old who brings home everything. Yeah, it's like a vector. Yeah. And it's made a really big difference. And glutamine also is it's consumed by activated T cells. Right. A lot of work on that. And,
used for cancer, and treatment sepsis and things like that.
Yeah. So it would be interesting to see if there's any effect of both of those, but even just looking at creatine as well. I know glutamine's been shown in endurance athletes, like who are very prone to respiratory illness, like these marathon runners. Yeah. Really, like they're really just getting to that catabolic state, right?
Yeah, it's interesting because I was the first to do glutamine very high dose in weight training, based on the premise that, if it did have anti-catabolic effects for cancer, long duration, and that was my master's thesis, and we didn't see any effect, probably going back to our initial start, where resistance training might not be stressful or catabolic enough in continuous duration compared to long duration events. So that's very interesting. Yeah.
Are you familiar with any of that work of the long distance runners and glutamine? There's like a few studies showing that these marathoners and stuff, they don't get as many respiratory illnesses if they're taking glutamine.
Yeah, no, I'm very familiar. I had to do the whole literature search, and it was a higher dose, and they also looked at it for sepsis, but the immune system response T4 and T8 I don't think were nearly as high. And that was from long duration. And a young, healthy individual, they probably might not notice any effect. But again, that was the idea, the premise behind it was more of an anti-catabolic. And why it didn't work for me, it was a non-essential amino acid. And of course, for protein synthesis, you need all the essentials. So it was a trying moment when I was doing my master's, but it works out in understanding it. Yeah.
Well, there certainly doesn't seem to be any shortage of interesting things to study with creatine. And it's like, the field is exploding. Right. So maybe someone out there will be looking at that at some point. Another really interesting area is the vascular health. And I mean, there's just like we were just chatting about a recent study coming out. Endothelial cells have transporters for creatine?
They do, right next to the astrocytes, which don't. So the endothelial cells at the blood-brain barrier especially, but around all the smooth muscle, they do have the transporter. So that was one of the theories. Mike Ormsby just put out a study, and Eric Rawson just recently in older adults. And that makes sense because you look at a population that might get some benefits. And they showed some very small favorable effects from creatine supplementation, either a week long or for up to 4 weeks, I believe. It was a loading phase and then down to about 5 grams a day. So it has some favorable effects for endothelial, I think it was macro and microvascular function. So that might have potential down the road for cardiac rehab or individuals with cardiovascular disease, or even subsets of that like type 2 diabetes or metabolic syndrome. So that's an area to stay tuned for as well. It's emerging. Same with type 2 diabetes. There's potential there as well, potentially improving glucose disposal. Again, if there's more muscle activation, you have more GLUT4 doorways, maybe more glucose gets in. So the Brazilian group is leading the way there. So it's gone from just athletes to now looking at the health aspects for a lot of different conditions, and interesting chronic diseases is come to the forefront, which is very exciting. Yeah.
I've also come across some other like cardiometabolic health benefits. So glucose, but also triglycerides and was cholesterol in there too? Can you talk about that? Is that maybe some mixed data? I'm not sure if everything is showing the same.
It's totally mixed. Some show decrease in triglycerides, LDL, and then others don't see the effect. And again, I think it comes back when you look at those studies with the population. If they're compromised as we get older, there's probably going to be more of an effect. And then the question is, was it dietary change that did it, or was it the creatine itself? So that's one of the big issues when we give a creatine supplement. If you don't consider what they're already consuming, or now they've initiated exercise compared to a true placebo, so there is potential. The mechanisms seem to be from a triglyceride perspective. It seems to increase energy expenditure, some thermogenic potentially effect that might explain why creatine decreases body fat in individuals 18 and above. But from the cholesterol perspective, we don't really know the mechanism there. And that's an area I'm sure that'll be exploding down the road. Yeah.
So creatine decreases body fat in combination with resistance training compared to resistance training alone.
Correct. Yeah. Now, small, about 1% or about 0.5 kilograms. There's some potential mechanisms there, but the thought is maybe increase in lean tissue mass, increase energy expenditure. So a lot of people are very cautious. They don't want to take creatine because they think it's going to increase fat mass. What the research is suggesting is increasing lean body mass, potentially decreasing fat mass. So usually the number on the scale barely changes after you do an intervention. Yeah.
Well, going back to this loading phase and this higher dose, I mean, when I say higher, I mean 20 grams.
Correct.
All these studies doing that, I mean, barring the brain stuff, is it really just to like kind of get their stores saturated quickly because the study is you're not going to wait 30 days.
Right. Yeah.
So it's really, all these other people trying to do this loading stuff, just kind of following the studies, but really they don't have to do that unless they like tomorrow when I hit the gym and have that explosive power benefit. Or
if you need a really quick effect, like rehabilitation from an injury, ACL surgery, something where you need to rehabilitate the muscle quickly, or you're an athlete, the loading phase to me is not needed from a muscle perspective. Now, because we've talked about bone and brain might need a bit more. So now maybe the new daily loading phase is maybe, 5, 10 grams a day or a little bit more. But that athlete, 20 grams a day for 7 days, followed by the maintenance, that is only ever been shown to have beneficial effects to muscle. There's been a few studies that have looked at it now from a brain, but again, that's from a different perspective.
You just brought up a point that I was thinking of, and that is surgery.
Yes.
and or injury. How does create, because that's a stressful situation.
Yeah.
We're talking about really creatine shining in that background of some sort of stress, whether it's training or sleep deprivation, but also you can have something like an injury or a surgery where you're planning a stressful event.
Yeah, it's multifactorial. The studies that have looked at it from a rehabilitation perspective, creatine seem to increase these things called myogenic transcription factors. So without boring your audience, these are little guys that sort of tell DNA to sort of increase proteins in a quicker way. So these myogenic regulatory factors went up during rehabilitation. And then we did a study when we got individuals to put on a cast, volunteer, and creatine seemed to maintain strength. Going back to the mechanism, it probably has to do that reduction in protein breakdown or the anti-catabolic, anti-inflammatory effect. Again, we don't think it has anything from a synthetic perspective because creatine doesn't, but it has been shown to increase satellite cells, which are needed for recovery and rehabilitation, growth factors, IGF-1, and decreases myostatin, the one that increases protein breakdown. So all of these factors come into play. It's like the caramel secret. There's a whole bunch of things that go into that chocolate bar. Creatine seems to work in a very variety of ways. And then again, on the other side, it's certainly been shown to decrease reactive oxidative species. So it seems to have more of a preservation to the cell effect. But from an injury perspective, it seems to speed up recovery. Do we know, would it speed up recovery if you took it before surgery? The jury's out on that. We'd have to do ACL surgery or studies on that in long-term clinical trials. We see a bit of promise in osteoarthritis, but not a lot of other ones. And because basically the studies haven't been done. Yeah.
And what's the dose on some of those?
These are usually the loading phase with a slight maintenance phase, or if they're looking at it from a cellular perspective, it's usually just the loading phase, 7 days pre-post. They'll do biopsies or cellular data.
So the 20 gram a day loading phase, and then the maintenance phase being
about 5 grams.
About 5.
Yeah,
okay.
Yeah.
And if someone's already taking, let's say, 5 or 10 grams a day, and then they're going to have a surgery, do they still need to do the loading, or should they just continue on?
I would just continue on, or even slightly a bit more, because when the tissue is under trauma, you get heightened inflammation, reactive oxidative species or stress, and then protein breakdown. So maybe it could help speed up your ability to recover quicker. We don't know any of the effects of creatine on cross-education, where if someone has an immobilized limb and they train the opposite limb, we don't think there's any effect. It's a great study to do, and that could have huge applications for professional athletes or individuals that are waiting for ACL surgery. Instead of sitting around all day, go to the gym and train the healthy limb, and maybe creatine could potentially increase more drive there. It's a study I've always wanted to do. We just haven't done it yet.
Okay, so it sounds like, in most cases, the creatine plus the training, resistance training or endurance training, is the key. But in some situations when there's just a massive amount of stress from, perhaps an injury or surgery or sleep deprivation, creatine can shine on its own.
Yeah.
Is that correct?
Yeah, there's actually a small body of research in healthy individuals, young and old, that say creatine without exercise actually improves muscle performance. So those that I think of disuse, bed rest, immobilization, sedentary individuals, maybe they have functional mobility issues, or people that don't know or have access to weight training. Creatine by itself has been shown to improve muscle performance, improve strength, endurance, their ability to perform repetitions to fatigue, primarily in older adults, but there's been studies in younger individuals, and that's sort of where creatine research blossomed. All the initial studies were very acute, 7 days, the loading phase, and then we saw improvements over time on muscle performance, and that sort of paved the way to lifelong interventions, which include exercise, is the main thing, for sure.
Yeah, exercise is definitely the most important thing. But I know I'm going to ask you to speculate a little bit here. But let's say you do have an older adult who is sedentary, and just getting up out of a chair is hard. It's challenging. It can be challenging. Do you think that even supplementing with creatine in that regard maybe help them a little bit more?
2 meta-analyses have been performed, both in Canada. We were fortunate to do one. Stu Phillips, I know, has been a guest, I think, for you. And we've done 2 meta-analyses. And then when you look at creatine in older adults with resistance training, though, it did improve tasks of functionality, sit to stand. So getting out of the bed, off the toilet, getting out of a chair. Again, that was with exercise. Without exercise, nothing has been there. So I would love to say yes. But again, the movement of exercise. But the nice thing is, for those willing to do, is it resistance bands, anything that you feel mechanical stress, creatine will give you a slightly greater benefit. But for those that are in jeopardy of chronic disease, I think you should consider it. Absolutely. Yeah.
So another question of mine, you were talking about where creatine transporters are, where it's synthesized. You mentioned it's created in the liver and the brain, but you mentioned it goes to the testes.
There's a little bit down to the testes. So any organ that only has the enzymes to make it, so since it's made in the liver and brain, it'll be dispersed to other areas. So the interesting thing is the area that it's created, it goes through circulation through different transporters. So male fertility has become a big issue. And there was a thought that, creatine, since sperm it's a flagella, so since sperm are relying for movement on creatine so much, maybe it's down-regulating sperm production. And my good colleague out of Norway, Serge Ostiak, who's one of the world's best creatine researchers, has looked at this in many forms and not showing any effect of anything. It improves the vitality and mobility of sperm. So that could have huge implications for male fertility. So, yeah, it's an area that you probably would never think of, but it's an area that has shown some evidence-based research behind it, yeah.
And that was going to be my question.
Okay, sure.
Is it affecting fertility?
Yeah.
It's going
seems
to
like
testes.
It improves it. So, again, that could have applications for individuals trying to start a family or male fertility issues. We don't see any down-regulation. There's a thought of taking in supplementation. Maybe that'll give your brain and liver a bit of a break. And there's evidence to suggest that maybe if you're taking creatine on a daily basis, those organs don't need to make as much because you're offsetting that. But again, when you stop supplementation, it goes back to baseline, or it doesn't disrupt any of that. And the good thing is, from a fertility perspective, there's no evidence to suggest it downregulates sperm motility health. We can talk about hair follicle loss and thinning, the same idea if the viewers were looking at me, but that was the same idea. Maybe creatine was causing baldness, so maybe it must be doing the same thing to sperm. It must be killing off the cell, and we just don't see any of that research. Yeah. So.
Well, good. Yeah. Well, let's get into those myths. But before we get into those, I kind of wanted to. We've talked a lot about adults. We've talked about older adults, the effect of creatine on many different tissues in those populations. But at the start of this podcast, you said something that caught my attention, and that was you said children and you said pregnancy.
Yeah.
And, I'm a mother of a 7-year-old who's quite active and, plays soccer and tennis. And I've often wondered, can children take creatine? I mean, obviously weight adjusted, but has there been any, evidence in children? Has anyone looked at children besides the TBI study?
Yeah. No, there has. Chad Gersick and Andrew Yagam at the Mayo Clinic here in the United States are the two most profound researchers in that area. And they've looked at study after study in children, young children, adolescents, and there's no adverse effects. And why would there be? If our body doesn't like it, we just excrete it. And there's a big push right now in some states trying to ban creatine in younger individuals, and they're just not looking at the evidence-based research. So overall, there's no adverse effects. We still need to do a little bit of blood work, but it improves health, agility, coordination, muscle mass. There's no reason. And so that's why I'm one of the big proponents. I argue, including the fetus, why someone couldn't take creatine if we're already producing it. It's not like caffeine, a drug effect. We're already producing it. That's like telling people you can't take protein in your food or supplement. That's just nonsensical. So I'm one of the big people who say anybody can take creatine. Even if you have chronic kidney disease, there's some benefits because it'll help the kidneys absorb creatine. And so right now there's potential benefits for children. For pregnancy, Stacey Ellery in Australia is the leading researcher there, and Abby Smith-Ryan in UNC. And so they're actually looking at fetal development, having more brain bioenergetics for the female. We now know that the transporter from breast milk is there. And then when you look at habitual diet, again, Serge Ostiak has looked at Ann Haynes data. And for those children taking less than 1 gram, it leads to a lot of potential detriments later on, cognition impairments, lean body mass, bone minerals. So, I mean, a serving of salmon is about 3 to 4 grams of creatine. A hamburger would even have that. So again, in habitual diet, unless the child is vegan, they're probably getting a little bit of amount. And the dose, 2 to 3 grams, or you can even do 0.1 gram because they're so much smaller. So if I had a child, I just have animals, a dog, I would give my children's creatine for sure as early as possible because I'm looking at brain development, bone development, muscle, immune system. It has all those benefits. And keep in mind, if our body didn't like it, we just make expensive urine. Like we just excrete it. People see this when they go for their blood requisition. They see creatinine on this blood requisition form, and that's all it is, a byproduct. So it's very safe. The safety profile is exceptional. Yeah.
Wow. I mean, so a few things here. So with respect to the dose with children, so you said 2 to 3 grams or 0.1 gram per kilogram body weight,
Yeah.
or is that applicable to the children as well?
I mean, if you want to do 5 grams or more, I don't see any reason why not. Do they need to be taking the 10 and 20 grams? We just don't have the data to support that. But a low dose, 2 to 3, 5 grams is totally viable.
And vegan kids probably even more so.
Correct.
Right? And then
That's right.
pregnancy, has there actually been any human data looking at women supplementing with creatine being safe?
Just subjective questionnaires, how they're feeling, things like that. It's too dangerous in a sense because we just don't know yet. And to get an ethics board approval at a research institution is very difficult, even for teenagers and adults under the age of 18. So I know Stacy is in our Big Myths paper is concluded that we need more randomized control trials, a big trial, because we definitely want to get this one right and make sure it's 100% safe, not just for the unborn child, but also for the mother. So there's going to be a lot more data to come out. But overall, there's no reason to suggest there's any issues whatsoever. Yeah.
Yeah. And it all, again, coming to back to the vegans, that comes to mind because you're talking about women who are pregnant, who are only relying on their liver, ability to make creatine, right? So that would be phenomenal to get a study like that done.
Yes.
But do you think it'll be approved?
I think down the road, when they look at the hypoxic environment of fetal growth, I think it probably will get approved, but we're going to need a lot more clinical data to suggest it's safe and maybe a pilot study in that. The issues with pilot studies, they're usually low sample size. So then from a feasibility perspective, it might I can see it in a multi-country to get a lot of people in different countries to come together and make the sample size that high. So that's something to look out forward to as well, especially in addition to the neurodegenerative diseases. Yeah.
I know I'm jumping all over the place here, but going back to the kids, you mentioned that creatine supplementation was shown to improve agility. Now, why is that? Is that because of the type 2 muscle fiber?
Or the motor unit recruitment, or maybe muscle activation. So there's a whole plethora of ideas from a balance, agility, coordination perspective. It could be that they're able to exercise at a higher capacity, sort of almost hyper accelerate muscle development. Those are all the things that are in its infancy to look at. Again, there hasn't been a study to look at blood biomarkers for like liver and kidney enzymes, but I would be very surprised if a low dose study was done and there was any issues. Yeah.
Okay. Yeah. Well, getting into some of the supplementation, questions, and I think we've kind of you touched on quite a few, but I want to kind of dive a little bit deeper. You first mentioned, of course, I think a lot of people that are familiar with the creatine field know creatine monohydrate.
Correct, yeah.
Creatine monohydrate. Is that still the gold standard for supplementing with creatine? If so, why?
Yeah, it's the only standard. So when I say creatine today, it's monohydrate, and the reason being is based on its safety and efficacy. So monohydrate means that creatine is linked to water. So when it comes through your GI tract, the water diffuses in the hydrochloric acid of your stomach. So that molecule, it's very unique. It can actually get through our small intestine intact, unlike protein, which gets degraded. Creatine is very unique. It's because the acidity of our stomach is actually too acidic. It doesn't like it so much. So it gets through. And then when it gets in our blood, the creatine that you're taking from supplementation monohydrate is identical to what's being synthesized in the liver. So that's likely why the safety profile is so exceptional. Now, there's probably 50 different other marketed forms of creatine out there. First, it has to be creatine when it gets into your blood. So whatever marketed form you want to try, make sure it is creatine getting into the blood or it's useless. Second, no other creatine has ever gotten into the cell and had superior effects. There has been a few studies that look at creatine hydrochloride and with the ester bond to get sort of through the phospholipid bilayer of your cells quicker, but no study has ever showed it to be safer or more effective. So I know monohydrate has been boring. It's been around since the 1990s, but in my opinion, why mess with a good thing? and probably because of the efficacy and safety behind it.
Well, why do people turn to these other forms? Is it because of GI distress that can be experienced with monohydrate?
Right.
It seems as though like I get mixed reviews.
Yep.
I'll talk to like almost like 50% of people say, hey, like I get GI like stomach distress, GI problems if I take creatine monohydrate. Some people have to go to another form or they have to lower their dose.
Right.
Why does that happen? Are there any ways around that? Is there like any tricks to improving, the ability of your stomach to digest it?
I think 99% of it is marketing. I think people get conned into buying something that's more expensive or flashy. And maybe they're making some errors with the monohydrate they're taking, and probably from the loading phase. So creatine monohydrate has been shown to increase intracellular water. So it's based on the doorway. It sort of brings water with it. And some people get GI tract irritation or some weight gain, and other forms of creatine are marketed to not do that. I argue if it doesn't do that, it's probably not creatine. In other words, creatine is osmotic. If you're taking a form of creatine that doesn't increase intracellular water a little bit, I would question the validity of that type of creatine. So I'm in the camp of 100% monohydrate based on the mechanisms, the structure of the molecule, and the efficacy behind it. Do you need to spend more on a fancy type of creatine? If it works for you, I'm all for it. But at the end of it, I don't think you need to.
Well, the question is, like getting back to what you said, if it's not increasing intracellular water, then it may not be doing what it's supposed to do, and ultimately that's the whole point. So the question is, if you're taking creatine HCl or there's liposomal creatine, or there's a GNC brand that's like it's an AMP creatine HCl. So it's like at the end of the day, the bulk of the research is done using monohydrate.
And 99% of all the thousands of papers. And the one I hear a lot is there's a better bioavailable form than monohydrate. And I'm like, wait a minute. Creatine monohydrate's bioavailability is near 100%. There might be a little bit extracted from the gut. So how can you get more than 100%? And then if it even got into the cell, I've never seen a study to show that it increased protein synthesis or had any of the effect on satellite cells or whichever. I'm only aware that it increased creatine content. So the good thing there is in those cells, I think it was hydrochloride. That means it is a form of creatine, but did it lead to performance benefits better than monohydrate? I've never seen it. So I just caution people, just don't get conned into a lot of these marketing forms, really expensive forms when monohydrate is the one true and tested. I'm going to Germany and we're going to be talking for 4 straight days in 2 weeks on monohydrate. Why? Because that's what all the evidence-based researchers need to talk about, because it's the only form that seems to be very viable. Yeah.
Well, aside from the marketing, I think I know some people personally that even taking like a 5-gram dose of creatine monohydrate experience like stomach issues.
Yeah.
So what can those individuals do?
Yeah, so I recommend to these people, and it happens quite often, the sort of microdose. So I would say if you're taking 5 grams, take about 2.5 grams in the morning, wait at least 6 hours and 2.5 grams later. Also take it with food. So I have for breakfast, I'm sort of boring, but I take Greek yogurt, collagen protein, whey protein, blueberries, and I usually put 10 grams of creatine in my yogurt. But some people can't. So if you want to put 2.5 grams there. But if you want to start as low as 3 grams, 1.5 in the morning, 1.5 in the evening, or you could do 1.5 in the morning, another 1.5 with lunch. With food seems to increase the absorption because of the insulin from carbohydrates and or some of the effects of fat. The most times is when people just drink it with water. I find that's where they get the GI tract irritation, just because it's going through the GI tract quickly, taking water with it. But with food, whenever we tell people that, they say it all went away. Yeah.
So that would be an interesting experiment for someone to try that's experienced GI problems.
Correct.
To try taking it with food, and carbohydrates seems like it might be
really good.
Really good. Okay.
Yeah.
So and then the other thing is you're talking about like lower dose, microdosing and spreading it out. Is that something you'd have to do like forever, or is that like to kind of get your gut used to it, or is it
kind of
really?
Both? It's almost from a consistency perspective. But there was a study done in 2003 where they showed a smaller, more frequent dosages were better than a super large 20-gram bolus dose. So it's almost like this retention idea. But taking, multiple 1.5 gram dosages or whatever, it might not be feasible on a daily basis. But, a quarter of a teaspoon, 2.5 grams, whichever, that would get your body used to it, then slowly titrate up. So the best way I usually tell people is start with 3 grams. 1.5 morning and evening, then move it up to 5, 2.5, then move it up to 9. But then I say 3, 3, and 3. And then eventually you're sort of getting tolerated. It's like caffeine, starting with a small coffee and working up to a large. Your body gets used to it, and then there's more in circulation. Yeah.
Well, you said these smaller doses were more effective at what?
The idea was that it would get into the blood, maintain peak or plateauing plasma levels, and hopefully you can retain more than some being excreted as creatinine. The thought was a super mega bolus dose of maybe 20 grams. Now there's new evidence it can get in the brain, but there's logic like some of that would be cleared from the kidneys, and because the muscle may not be able to take that in all at once. Yeah.
Okay.
So dosing studies need to be really done. Yeah.
Well, this kind of goes to another question I had, which was, we've been talking a lot about dose,
right?
But it's also about, if you're taking the cycling of it. Mm-hmm. So, some people like to slam their protein shake right after a workout. Yeah. Is there any reason to worry about that with creatine? Because you're talking about saturating the stores. Yeah, so it seems like it's you're trying to saturate the stores.
Yep.
I don't know that cycling around that's going to do anything.
So that's a two-part answer, I think, from a timing perspective and cycling. So from a timing perspective, unlike caffeine, we don't think the timing really plays a major role. There is one area that I would just recommend. It's post-exercise or pre-exercise. And the reason for that is that we think blood flow or transport kinetics is turned on with muscle contraction. So if you want to take creatine within an hour before your workout, or I drink 5 grams during my workout or right after, that seems like a very viable time. But for the viewers, the timing seems to be irrelevant. But that begs the question, what about cycling? So if you've been taking creatine for maybe 2 months, 3 months, it's very likely your muscle stores are so saturated that when you're consuming the extra creatine, that you would just be excreting it. So some people say, hey, I don't want to do that. I don't want to waste my money. I'm going to cycle it. I now argue you should take it on a daily basis because of the emergence of okay, I'm okay with the muscle being full. If someone's going down the toilet in urination, that's okay. But now I'm hoping our bone is taking in some. Our brain is taking in some. So we used to be in the camp where you just need creatine on the days you work out. Now I say take it every day and hope some is going to go to your brain and muscle, bone, because on the days you're not working out, your muscle is not sucking it in as fast. Maybe those other tissues are getting replenished.
So do you think it's better to take creatine, you taking it in the morning if you're going to work out in the morning, but what if you work out in the evening? Do you want to take it in the evening?
Yeah, I would take it in close proximity to exercise. I would take it. So if you work out twice a day, you're taking creatine twice a day. But if you take it in the morning and then work out later in the night, that's totally fine. We're not seeing any big differences. But I'm a big advantageous proponent of taking in close proximity to exercise, and that's within an hour pre and post.
Okay, so some of the other questions are interaction with other supplements, other compounds. For a very, 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 very long time, I put creatine in my coffee. I put everything in my coffee because it just masks everything, and I just didn't do it in one. Right. I've never really had any GI problems with creatine supplementation myself. Okay. So, but I'm not sure that I'm supposed to be doing that.
Yes, so I'm one of the rare people, and most people argue against me. I don't do it either. So there's two ways to look at this. The pharmacokinetics of creatine and caffeine do not oppose each other. But from a cellular perspective, they certainly do. So remember when I talked about the sarcoplasmic reticulum, caffeine likes to release calcium, but creatine likes to take it in. And some really good research out of Europe have shown that the two molecules oppose each other from a muscle relaxation time. But the dose of caffeine seems to be the most important factor. If the dose is over 250 milligrams or even higher, that's when it seems to have the interference effect. If the dose is lower, it doesn't seem to have an interference effect. So the average large black coffee from Starbucks might be 400 milligrams of caffeine. So if you were to put your scoop of creatine in there and sip on it for hours, you probably won't notice an interference effect in a few times. But if you did that every day for months, you might notice a blunting effect. If you did it a one-time shot, you were doing an experimental trial, you might not notice it. So I never combine the two. I always have coffee early in the morning. I love coffee. And then I wait at least 2 hours before I take my first thing of creatine in anticipation of that cellular interference. But other people, other big-time creatine researchers say, no, I take it together. If it works for you, great. but there's something there that makes me a little cautious. And we've done the only training study. It was underpowered, but they did interfere with each other.
Yeah. Okay. Yeah. Is creatine heat sensitive?
It is. It denatures a little bit. So if you warm up the solution, some people don't like the grittiness. So when the temperature rises, it will decrease or increase the solubility, if you will. It will not degrade it to creatinine unless it's super heated for a long period of time.
So if you are putting it in your coffee,
the heat is not the act. It seems like the caffeine molecule might be the one that might interfere with it.
Okay, so you don't have to worry so much about it being in like a hot liquid, like tea or.
But if you had a normal K cup is 80 milligrams, there should be no interference effect. You could have 2 of those, but if you get up to like a large coffee, so a normal cup of coffee here in the United States, maybe 80 to 100 milligrams should be totally fine. Yeah.
Okay. Well, this is all really good information. I think addressing some of these, the myths and, questions, the misconceptions,
Sure.
I mean, all those things, because you've published a couple of meta-analysis or review articles, I guess, or review articles on this. And so you talked about, let's talk about the fat gain, right? So that was kind of when you touched on a little bit. I mean, especially women. Is it really just because of the lean mass increase?
There has been some cellular or animal data to show that it increases thermogenesis. But overall, the decrease in body fat is there, but it's very low. So don't run out and buy creatine and think you're going to lose 20 or 30 pounds. We're seeing at best about a 1% decrease in body fat and about 0.5 kilogram reduction over time in combination with weight training. Now, that could have implications for obesity, type 2 diabetes, or chronic diseases down the road. But the nice thing is a lot of people had a myth that creatine increased body fat. We don't see any evidence to that.
Okay, so it's doing the opposite.
Yeah.
The hydration myth. So what about... I've heard some people talk about cramps. It causing cramps or dehydration.
It's opposite. It superhydrates the muscle. So it could be from the sodium potassium pump or disruption from dehydration. But if you're metabolically dehydrated, creatine is not the cause. If anything, creatine is trapping water into the cell. It also has been shown to increase extracellular water and total body water in some studies. So from a cramping or dehydration perspective, it's actually opposite. So for those exercising upcoming summer months, NFL football players, 2-a-day practices in July, creatine might actually help hydrate the muscle and decrease the chance of muscle cramping or dehydration.
Ooh, that's super important. Interesting.
Yeah.
Has anyone directly looked at that?
I think Rick Kreider's done some studies with that when he looked at NCAA players, but a lot of people don't take it. The myth was that it was dehydrating, and we just don't see
Where did that myth come from?
I think what happened was in the inception of creatine research, a lot of people were not drinking water or going through some practices like wrestling, wearing rubber suits, extreme hydration. They happened to be taking creatine, and then they said, well, I'm on creatine. Since it traps water, therefore my cells must be exploding, or muscles, and therefore it was causing cramping. And we just don't see any evidence behind that. Yeah.
Okay, so it was like a correlation thing. Where
unfortunately, it was the opposite, and then sort of went with
Okay, we've talked a lot about the kidneys, and you're talking about creatinine, and I'd love to talk about that. That's one that I hear a lot.
Yes.
That it's bad for the kidneys, it's bad for the liver. Can you address that?
It's probably the biggest concern. So we've looked at study after study, and rest assured, from a clinical perspective, creatine does not adversely affect renal, liver, or cardiovascular cells. And we've given 11 grams a day in postmenopausal females to a population where their organs are under a little bit more stress and no adverse effects. The theory here was that when creatine enters your muscle, when it gets metabolized, it's non-enzymatically metabolized as something called creatinine. And those watching say, oh, wait a minute, I just saw that my doctor checked that off. And the reason they do that is creatinine is a byproduct. It's supposed to be filtered by the kidneys. So if you have high blood creatinine, that means your filtration rate in the kidneys is not working properly. Think of your Brita water filter. It's clogged up. So unfortunately, when a lot of people go to their doctor, they don't say, hey, to the nephrologist or GP, I'm on creatine supplements, because it's logical that if you're taking creatine, your creatinine might be acutely raised. And then that causes a false positive. Your estimated filtration rate is low. So your doctor says, whatever you're taking, stop. It's killing your kidneys. We know that's not the case, because when they do stop, their kidney function just comes back. So it's just the metabolism of the molecule.
Okay, well, this is really important. I've had a few people reach out to me and tell me that their creatinine was elevated, and I don't think they told their GP that they were taking creatine.
Yeah.
And so the idea here is that it's the metabolism of the creatine to creatinine that's being excreted through urine.
That's right. So creatine and phosphocreatine don't leave the muscle. It gets left in the muscle as creatinine. Creatinine can also be raised with a very, very high protein diet, excessive exercise, or dehydration. But make sure if you're on creatine supplementation, tell your doctor, because it's logical that your creatinine in the blood will be elevated. That's just from the metabolism of the supplement. Now, if your liver enzymes are through the roof, that could be an infection. So again, make sure you go and get medical screening and guidance. But every time we hear this, it's usually a false positive.
I see. Yeah. False positive.
Yeah,
okay,
false
so it's
positive.
really good to talk to your physician about that. Baldness. That's one.
Yeah.
It was the rugby. Was it rugby players?
South Africa. Yeah. I was going bald way before I started taking creatine. So a lot of people say, oh, well, obviously. And it's interesting. It was a great study in a sense that they looked at a novel concept. So they had elite rugby players do a crossover design, and a crossover design is really powerful. That means the group gets both placebo and creatine. So it really controls for diet, genetics, hormones, things like that. And when they took 20 grams a day, it might have been even 25 grams a day for 7 days, during the creatine supplementation phase, they increased the hormone dihydroxy testosterone, or DHT. And most people say, oh, I think I've seen commercials about this. It's a surrogate of testosterone, but it's been highly linked to hair follicle loss and thinning from a cellular perspective. They measured it in the blood, so the correlation, it's just a surrogate. But when they went up, I think it went up by about 57%. But it was still within the physiological range. And what I mean by that is when you go to your doctor and they measure your blood glucose and it comes back and the doctor says, no, it's within the normal range. Cholesterol's in the normal range. Even increasing by 57%, I think that was the number. It was still within the normal range. When they were on placebo, it increased by about 40%. So everybody says, whoa, hormone went up, correlation, causation. Everybody was freaking out that this hormone went up. They did not measure hair follicle loss, thinning, cross-sectional area. No dermatologist was involved, but a lot of people have run with this, and to this day, they cite this single study that even didn't look at free testosterone. There was no increase. So just because DHT went up a little bit, and they started lower, so there was more room to improve, people think it causes baldness. I've assessed easily over 1,000 people, males and females. Not a single person has said, hey, whatever you're giving to me, double blind, is causing my hair to fall out. And I got to believe a participant would say, I'm not taking this anymore. My hair's falling out. And I do know, I can't talk about it because I'm not sure, but I do know that there's been a paper submitted that have looked directly at hair follicle loss and thinning with creatine supplementation.
And that was going to be my next question. Yep. I mean, first of all, has anyone replicated this study? It sounds like no.
No.
And has anyone, directly looked at hair follicle?
It's in review right now. But if I had to have a magical guess, it doesn't affect hair follicle loss or thinning. So if people are watching me, they're like, oh, and then they look at other creatine researchers, I can blame my parents and primarily my mother for that, for the maternal DNA. But then there's other people with full heads of hair. So it can't be a cure. It's like, carbohydrates cause obesity. That's nonsensical. It's everybody's different. But I still get this on a daily basis, both from males and females. They don't want to take it or their hair is thinning. And I'm really glad that this study is coming out, because the way we should have answered this is we don't know. Until a study emphatically says, no, we didn't see any of the effects, we would have to say we don't have any evidence to suggest it does, and we don't have any evidence to suggest it doesn't. And even when the study gets published, we'll probably have to do multiple, but it just has never been done.
And no rodent studies?
No rodent studies, nothing. I think it's an area that people said no one cared about, and then all of a sudden everybody cared about it. Yeah.
That's so. Is there any other really, I think, prevalent misconceptions or myths that you want to talk about or know about?
There's so many. I think the big one the big one we're getting a lot is, does it increase hypertension or blood pressure? Because if it increases water into the body, could that have any effects? And we're not seeing any adverse effects there. The other one is we do not see any evidence it disrupts sleep. Although we talked about the study earlier, it doesn't have any negative effects there. And then cancer. So this is an area that is difficult to answer or talk about. because we just don't have a lot of human cellular data. From the in vitro data, we're not seeing any in humans, at least from recommended dosages, any malignant growth or any cancer promotion. If anything, we're seeing anti-cancer properties from improving or anti-inflammatory responses there. And in our latest paper, The Myths and Misconceptions, Part 2, one of the world's best creatine researchers and medical doctor, Mark Tarnopolsky, read really good section on that. So if anybody's interested, read that. And it seems to have some potential for cancer rehabilitation. When you're looking at tissue loss, cachexia, it seems to have some beneficial effects there. And I'm collaborating with Kieran Fairman in University of South Carolina, looking at prostate and breast cancer rehabilitation. So I think you're going to start to see some medical applications growing more than just young, healthy individuals. Again, the common denominators, all these are sort of asking something for help. It's either rehabilitation or prevention. And that's where I think creatine has really changed. It used to be for just young individuals who are healthy, and now it seems to have some of these health aspects. So very exciting times to be talking about it. Yeah.
Are you familiar with any of the research of Dr. Carrie Cournier?
Out of University of Alberta.
Yeah.
So cancer there. I don't think he's ever looked at creatine, but he does a lot of community-based. Yeah.
I just had him on the podcast, and he was, he does a lot of the role of exercise in cancer treatment, and not just aerobic, but resistance training. So that would be interesting for you guys to have a discussion.
Yes.
The other thing that came to my mind that I now remember, I've heard a lot of people talk about, is creatine supplementation increasing their urination, particularly during sleep, like having to go urinate more frequently.
I just answered this question on Instagram. So an individual, because I said I take a pre-sleep sometimes, and that'll keep me up peeing all night. And I said, oh, actually, that's interesting. So in this Myths and Misconceptions paper as well, there's a section there that the creatine molecule, whichever, does not increase urinary output. People thought since it's creating creatinine, you need to filter it. We think it's the increase in fluid ingestion that you're probably taking either with exercise or what is usually recommended with creatine. That's actually a myth as well. You don't need to increase tons of water consumption, but the molecule doesn't cause an increase in urination. It's not a diuretic, or it doesn't increase urinary flow that way. I do hear that a lot. My logical guess is you're probably putting the creatine in 8 ounces of water, and you're probably drinking more water or exercising, and that's one of the things. But there's no evidence to suggest the molecule itself stimulates urination. Yeah.
Okay. Well, that's good to know. I think we've covered a lot. There's one area I did want to talk about, and we talked about kind of saving at the end because there's more speculation here. And this is just an interest of mine. I remember several years ago, a former colleague of mine, Mark Shiganaga, was talking to me about, creatine production in the liver being one of the biggest sort of sinks for methylation. And that's because you need methyl groups to produce it.
Yes.
And as a byproduct, you also make homocysteine. And so he was talking about at the time, I think it was pretty preliminary, but some evidence showing that if you did supplement with creatine, that the enzymes in the liver that do produce creatine there was a feedback, and they sensed that, and they didn't use so much of the methyl groups were being shunted to other methylation pathways. And so I was just wondering if you've come across any evidence looking at creatine supplementation and homocysteine levels, for example.
Yeah, the most studies don't support it. And that's where we got to the point where, if it doesn't decrease homocysteine levels, then maybe exogenous creatine doesn't reduce our natural creatine synthesis. The studies that show it does are in animals, and I believe there was one human trial, but the majority shows it doesn't have any effect. Now, that could be the dose there, but you're totally right. Methionine is donating, I think it's 40% of our methyl groups to creatine synthesis. So if I'm taking more dietary creatine or supplementation, why use that? Why not decrease the amount being synthesized? Because that has huge implications on endothelial health and cardiovascular health. But ironically, it's not even equivocal. The majority suggests it doesn't decrease. Maybe the studies are not long enough, or maybe they're not in populations that need it as much. Yeah.
Right. So the question is, maybe you need to start with a population that has elevated homocysteine.
Correct. Yeah.
Right.
Vegans. Yeah.
Because it's hard. It's hard to detect small changes when you already have.
And it's easy to do. You just look at some of these blood biomarkers, but there's not a lot of. There's probably less than 10. Majority in rodents, a few in human, and I think last time I checked, it was probably 7 against, 3 supported it. So there's a lot of methodology issues there. Yeah.
Well, maybe someone will look at
Yeah,
it. I mean,
absolutely.
That would be...
Especially as we start to get into the vascular health, for sure. That's a huge area. So I would be shocked if more studies don't come out in vascularity health or angiogenesis or anything like that, potentially looking at homocysteine as a surrogate marker for potentially explaining some of the effects.
Yeah.
Because if homocysteine comes down, you would speculate endothelial health would go up and some of those things, yeah.
Right.
Yeah.
Well, if you talk to any researchers doing vascular health research with creatine, that'd be great.
Yeah.
So I think we've covered pretty much just a lot of ground, really interesting stuff. Did we miss anything? There's anything that you wanted to discuss?
Oh, geez. No, you hit the caffeine one. I knew that was an important one for people.
Are there any other interactions with other?
Let's go back to the carbohydrate one, because I think people hear this. The best way to augment creatine into the muscle is with muscle contraction, which is great. But the dose of carbohydrates shown to sort of increase it is almost over 75 grams. And I think most people are not going to consume that. Protein is a great one to add creatine to because it's insulinogenic as well. So combining creatine and protein will probably give you a superior effect. And there's been 2 studies that show you get a greater increase in muscle performance and lean body mass when you combine creatine with protein. In this protein case, it was whey protein. It was only about 30 grams. So now when you're looking at your post-exercise meal, pre-exercise meal, I think creatine and protein are good friends. Consider them as something that you may want to consider, especially in your post-exercise meal, or like I take at least 50 grams of protein with breakfast. I put my creatine in there. I don't need to worry about it until later on, and then I usually drink it or have it with a meal. Most creatine is tasteless. You can put it in food. That's fine. You can, the heat would denature it a little bit, but it's something to consider. Yeah.
I'm glad you brought this up because to clarify, maybe some people were confused when we were talking about this earlier. Taking the timing of the creatine around exercise, it was to improve the uptake of creatine into muscle, and that can be done before or after, like in close proximity to the exercise.
Yeah, and if you don't want to work out, keep in mind it still accumulates, maybe just not as quick. So the study in 1992 was very elegant. They had one leg exercise, and that increased creatine uptake by about 37%. And in the other leg that didn't exercise, it still improved by 25%. So at the end of the day, the person, at home watching TV, taking creatine, whatever, for some time, they're still accumulating, but exercise unlocks a lot of the doorways, so to speak, that sort of get it in there more. So it might give you a little bit extra benefit. And that's why I say proximity to exercise is a very viable time to take it. Yeah.
But if you're looking for the benefit in terms of improving or increasing your training volume, in the explosive power, the strength, that it doesn't necessarily have to be timed around the exercise, right?
Just take it. Like if you don't want to take it all at once, take it in small dosages. I think consistency. I now recommend take it every day. Just get it like a multivitamin, whatever you're doing, but just keep in mind it's giving you not only exercise benefits, but I'm really happy to see the emergence of the health benefits. And I think in today's society, we could all use a little bit of help. Yeah.
It sounds like there's no reason not to take it. I mean, there's a lot of benefits, the muscle, the bone, the brain, very, very convincing. Yeah. Third-party testing, you can look for companies that have been vetted, that are reliable brands, and that's always like that's
a big thing that we didn't talk about. So if you are considering supplementation, again, you don't necessarily need it if you're getting it through your diet, but make sure third-party tested. I would really focus on monohydrate. Based on the evidence-based research. Monohydrate has GRAS status. Creapure is from Germany. It's the most scrutinized. It has less purities. That's an excellent form of creatine monohydrate. Make sure it's pharmaceutical grade. So all these things that you would do by putting something in your body, just do a little bit of homework. But if you're not seeing certified safe or third-party tested, that's something to be a little cautious. And the other thing is, when you're buying a compound or ingredient with a whole bunch of ingredients in there, we don't know if the creatine is going to be effective or not in these pre-workouts, things like that. There's no reason to suggest not. But when I've been talking about creatine in our experimental studies, we're giving 100% pure creatine. We're not giving it with 10 or 12 other compounds that you got at a grocery store, things like that. But again, so there's a little bit more work that needs to be done if you're considering a multi-ingredient compound. Yeah.
Yeah, and that's a good point because we were talking about taking 10 grams a day, which is your sort of go-to, and now soon will be mine.
Okay.
You don't want to take 10 grams a day of some mixture of things, right? You want it to be just creatine.
Yeah.
Now you mentioned creatine pure or
Crea Pure is
Crea
the
Pure
form of monohydrate. Yep.
That's very pure.
It's very pure from Germany. It's third-party tested. Now, as a disclosure, I'm on the advisory board for Crea Pure, so full disclosure. And that's helped sponsoring the creatine conference in Germany in a few weeks. But it has GRAS status. And when you look at the independent lab results, it's 100% pure. There has been some issues out of Asia with transportation and not being third-party tested. So I think the consumer just needs to do a little bit of work. Most companies nowadays, if you're on the shelves of a product, are very reputable. And again, if it has third-party tests, it's safe. Just look at the ingredients. It should say monohydrate, or if you're entertaining another form of creatine, that should be the only ingredient, or at least the most important ingredient on the product. Yeah.
What about microionized?
Yeah, that's a new form to get away from some of the things you mentioned on GI tract irritation. So that's just being continually processed. It's very fluffy. I've noticed some of the new products, it dissolves exceptionally well, get away from that grittiness that the creatine can cause in solution. So these are just coming up with new alternative forms to help please a lot of individuals, make it more attractive. But it's another form that can just sort of solubility is very high. Yeah.
Is there any reason to believe it wouldn't work? It's because it's monohydrate, right? So it should do the same thing.
100%. It's just a different way to get it into your body. If you like it really, really micronized, so it's pure fine. I just take normal creatine, and if there's a little bit of grittiness at the bottom, that doesn't bother me. But some people, they do. Yeah.
Okay.
Yeah. So,
well, excellent. We've just covered so much wonderful information, and thank you so much for taking time to talk about all this research with me today. Yeah. And thank you for doing all this research. I mean, really, you've just done an amazing job covering so much important, ground in terms of the effects of creatine on human health.
Right. Well, thank you so much for having me. Had a great time. Thank you.
Me too. Thanks.
Yeah. Thanks.
Thank you to Dr. Darren Candow for coming on the podcast. After this episode was recorded, a new study was published suggesting that creatine supplementation was not effective for increasing muscle mass. But that study is not what most people think it is. Dr. Candow, who was actually one of the co-authors of the paper, joined me to break down what the study actually showed, what the data support, what they don't, and how to interpret the findings in context. You can watch that full breakdown on the Found My Fitness Clips YouTube channel. And if you found this podcast valuable, please consider sharing it with friends, with family, colleagues, anyone who you might think benefit from this information. I think a direct link goes a long way. Thank you so much for listening, and I'll talk to you guys soon.